In section 5.4, we're going to continue our discussion of sum and difference formulas, whereas in the last section we did the sum and difference formulas for cosine. In this section we're going to focus on the sine and the tangent. I've written the formulas for the sum and difference formulas for sine. Notice they have the same flavor as the ones for cosine, but notice with sine of a minus b, you keep the minus. Sine of a plus b, you keep the plus. Remember, cosine, they switched. And the pattern for cosine of a plus b, a minus b, was cosine, cosine, sine, sine. For sine, you have the mixed term, sine, cosine, cosine, sine. So it has the same flavor, even though it's a different formula. So for that reason, the formulas were just like the ones in cosine in the last section. So I'm not going to do any examples in this section for the sine, because it works exactly the same. We're going to focus on the tangent, because that formula is different. Before we get to the tangent one, I want to talk about simplifying fractions and fractions. For example, if I have a third plus 2/5 over 6 minus a half. Well, what's the standard way that you usually simplify problems like this? You've got a common denominator in the numerator, which would be 15. You've got a common denominator in the denominator, which would be 2. You added the fractions in the numerator, subtracted the fractions in the denominator. You got a fraction divided by a fraction. You invert, multiply, and get your final answer. That's a lot of work. That's the correct way to do it, but it's a lot of work. Let me show you the way that I usually simplify fractions and fractions like this. First of all, I think of the 6, because it's not written as a fraction. Think of the 6 as 6 divided by 1. Now look at all of the denominators. I have a 3, a 5, a 1, and a 2. What's the least common multiple of 3, 5, 1, and 2? Well, these numbers are all prime. If you multiply, you're going to get a 30. The least common multiple is 30. So what I'm going to do is multiply this fraction by 30 over itself. Right? I'm multiplying by 1, so I'm not going to change the value of this expression, just the appearance. So I'm going to use the 30 and distribute. Because I chose the least common multiple of all the denominators are going to cancel out. So a third times 30, well, that's 10. 2/5 times 30, well, 5 goes into 30 6 times. 6 times 2 is 12. 6 times 30 is 180. And then minus a half of 30 is 15. Notice all the fractions are gone. If the fractions don't disappear, that means you didn't choose the correct least common multiple. And now this is very easy, what I say. So this is 22 over 180 minus 115 is 165. So very easy. So once you wipe out the fractions, you're just dealing with integers, and the calculation's not so hard. This is a whole lot easier than common denominator add, common denominator subtract, invert, multiply. So the reason why I bring this up is when you use the tangent formula in this section, sometimes you get expressions like this. So keep in mind, you can do what I just did here. Look at all the denominators, take the least common multiple of all the denominators, multiply that over itself, wipe out the fractions. That'll save you a little bit of work. Okay, with that in mind, let's focus now. I'm going to do some examples with the tangent, because it is different. Because tangent is a quotient. So, for example, tangent of a minus b is tangent of a minus tangent of b over 1 plus tangent of a tangent of b. Okay, so what's the pattern here? Tan of a minus b, you keep the sign in the numerator, and it's the opposite sign in the denominator. So tan of a, it's tan of the first minus tan of the second divided by 1, opposite sign of the product. Now what's tan of a plus b? Well, that's tangent of a plus tangent of b, keep the sign. And then the sign changes here, 1 minus tan a, tan b. So there's your tangent formula. So see how these are different. Notice you have quotients here. So you have something plus something over 1 minus a product. So it's a little more complicated than the sine and cosine formulas. On the plus side, notice there's only 2 things defined here. Tan A is here and here, tan B is here and here. Same thing here. If for sine and cosine, remember there are 4 different things defined. Sine of A and cosine of B, and sine of B and cosine of A. So there's 4 things defined there. There's only 2 things defined here. But you have fractions, so it's going to be a little more complicated. So as an example, it says find the exact value of tangent of negative 105 degrees? Well, I think the first thing I would ask myself, especially if this were, say, a problem at the end of on the final exam or at the end of the semester, is this one that we could do from chapter 2? So let me just quickly see that. So where's negative 105 degrees? Negative 105 degrees is here in the third quadrant. There's negative 105. Now what's the reference angle? All the way to here, halfway around is negative 180 degrees. That gives a reference angle of 75. I don't have a special triangle for 75 degrees, and so I can't go back to chapter 2 and do special triangles. So this isn't a problem from chapter 2. Well, it's the same idea as in the previous section with cosine. Can I rewrite negative 105 degrees as a sum or difference of two angles I can do? Well, something that leaps to mind here is negative 60 degrees minus 45 degrees. Negative 60 minus 45 degrees, that is negative 105 degrees. I know I can do negative 60 and I can do 45. Now, if you want to, you can think of this as plus negative 45. The way I have it written, I'm going to use this formula. So A is negative 60 degrees and B is 45 degrees. If you want to use this one, think of it as negative 60 plus negative 45. Use this formula, A is negative 60 and B would be negative 45. It's your choice. So I have it looking like this, so I'm going to use this. So this is tangent of negative 60 degrees minus tangent of 45 degrees. So my A is negative 60 and my B is 45. Over 1 plus tan of negative 60 degrees, tan of 45 degrees. All right, so I've rewritten my tan of negative 105 degrees in terms of angles I know I can do. So there are things to find here. So I have something minus something over 1 plus something times something. So there's two things to find. I need tan of negative 60 and tan of 45 degrees. Let me do the tan of 45 degrees because that's easy. That's our special triangle, 45 degrees. That's your 1 square root of 2. Now what's the tangent? Tangent's opposite over adjacent, or y over x. So tangent of 45 is 1. So those were there. So there's a 1 here and a 1 here. And then negative 60 degrees, that's in the fourth quadrant with a reference angle of 60. That's your 1, 2 square root of 3. So 2 on the hypotenuse. 1 is opposite the 30 degrees, and the square root of 3 is left on that side. And don't forget to check for negatives. They were all positive here in the first quadrant, but here the root 3 is negative. Now what's the tangent of negative 60? Tangent is y over x, or opposite over adjacent, so you get negative root 3 and negative root 3. And now we just need to simplify. Well, there's nothing to do in the numerator. It's something minus something, so that's minus root 3 minus 1. Now be careful, order of operations, before you add, you have to multiply. Negative root 3 times 1 is itself, so you just get 1 minus root 3. Now be careful, you cannot cancel the root 3's because you're subtracting. Everything is not being multiplied and divided. Now again, I'm perfectly happy with this answer. You don't have to rationalize the denominator for me. If you're interested in rationalizing, let me go ahead and show you how that would go. If you're interested. But I'm perfectly happy right there with that answer. Now you have to be, this one's different. Normally when you see a root in the denominator, you just multiply by that root over itself. Well, what's the problem here? Yeah, you'll get a 3 there, it'll go away, but root 3 times 1 is root 3. You haven't gotten rid of the root, so that doesn't work when you have a difference like that. What you have to do is multiply by what's called the conjugate. Change the minus to a plus. That's how you get rid of roots when you have a difference or a sum, but you have to multiply that over itself. Right? I'm multiplying by 1, so I'm not changing the value, I'm just going to change the appearance. So if you FOIL this out in the numerator, I get minus root 3, minus 3, minus 1, minus root 3. Let me check myself. So negative root 3 times 1 is minus root 3. Minus root 3 times root 3 is minus 3. Negative 1 times 1 is negative 1. And then minus 1 times root 3 is minus root 3. Now, if you do the same thing in the denominator, 1 times 1 is 1. Now, look what happens with the outside and the inside terms. You get plus root 3 minus root 3. Those subtract out. And then you get minus root 3 times root 3 is minus 3. That's why you change the sign, because it becomes a difference of squares. So the outside and the inside terms wind up dropping out. That's why we do that. And then if you simplify this, you get negative 4 minus root 3 is minus 2 root 3. And then 1 minus 3 is minus 2. And you can simplify this even further, because notice every number here is a multiple of 2. In the numerator, if I factor out negative 2, if I factor a negative 2 from negative 4, I'm left with 2. Factor negative 2 from minus 2 root 3, I get plus root 3. Always check your factoring by remultiplying. Minus 4 minus 2 root 3 over minus 2. And then your negative, it's something times something over something, so you can cancel your negative 2's, and you get 2 plus root 3. Notice this answer looks completely different from this one, but they are the same. Again, if you you can check your work. The problem said find the exact value, but you could type tangent of negative 105 degrees in the calculator, type this in the calculator, type this in the calculator, the decimal should match up. Again, be careful. If you type this in the calculator, you have to put the entire numerator in parentheses and the entire denominator in parentheses, or it's not going to compute it right. Okay, so that's that one. Notice I didn't get the fractions in the fractions like I mentioned you might get, but that's because of what I've chose here. You may choose other angles and get fractions and fractions, and you want to do that procedure I mentioned before. And then the last example I'm going to do here, which also involves tangents. Again, I want to practice with the tangent formula because the sines work just like the cosines in the previous section. And it's proving an identity. Now remember, what was the procedure for verifying an identity? Okay, start on one side and use facts you already know to work your way to the other side. So if this problem says, show the following is an identity. Tan of x minus y minus tan of y minus x is 2 times tan of x minus tan of y over 1 plus tan of x, tan of y. Goodness. Okay, so we want to start on one side, either the left side or the right side, and use things we already know to work our way to the other side. Okay, notice the procedure is different than solving an equation. Right? When you solve an equation, if you have 2x plus 5 equals 17, and it says find the value of solve for x, means find the value of x that makes this true. Notice the procedure is different. You start subtracting things from both sides, right? Subtract 5 from both sides. You get 2x is 12, and then divide both sides by 2, and you get x is 6, right? That's value of x makes the equation true, right? What's the difference? You started with two things you know are equal to each other. That's why you're allowed to do things to both sides. Right? Those proving an identity is different. I don't know these are equal. That's the difference. When you know two sides of an equation are equal, you can do things to both sides and get an equivalent equation with the same solution set. And here, I don't know these are equal. Right? I'm trying to prove they're equal. That's the difference. That's why the procedure is different. Now the question is, I usually pick the more complicated side, whatever that means. They're both complicated. This is a mess. This is a mess. You could argue the left-hand side is more complicated because the angles are more complicated. Notice the angles on this side are x, y, x, y. Just x's and y's. On the left-hand side, what are the angles? X minus y, y minus x. So it's not just the expressions and how complicated they are. I also look at the angles. If the angles are more complicated, so I think I'm just going to start with the left. And now the reason is, because I have an idea of what to do. Sometimes if they're both relatively complicated and you don't know, that argument's not helping you to figure out which side to start with, pick a side you have an idea of where to start. I don't know what to do on that side. I have an idea of what to do on this side. So I'm going to start with the left. always write down the side you're starting on so I will know, because everybody doesn't start on the same side. Okay, I need to know what you're starting with. And don't write equals that. I don't know that it equals that. Students will put this equals that, and they'll keep writing it. I don't know they're equal yet. Now, I said I have an idea of what to do here. Now, what's my idea? Angles here are x minus y and y minus x. Angles over here are x and y. So I really need to break this up. I don't want x minus y and y minus x. I want x's and y. So I want to break those up. That's what the the sum and difference formulas do for you in this section. So I'm just using the formula. What's tan of x minus y? If you use the notes there, it's tan of x minus tan of y over 1 plus tan of x, tan of y, isn't it? Right? That's looking pretty good. Minus, now what about this one? Now be careful, this is tan of y minus x, so the angles, they've switched roles here. So that's tan of y minus tan of x over 1 plus tan of y, tan of x. So basically I switched the x's and the y's here. So this is this, and this is this. The good news is, I have the, right, tan x tan y is the same as tan y tan x because of commutativity of multiplication. So I have the same denominator here. So that's great. So I already have the same denominator. So common denominator to subtract the fractions, I can leave that denominator alone. Now I want to subtract the fractions, so I have tan x minus tan y, no problem. Now let's be careful. It's minus the whole thing. So you have to distribute the minus sign. So I have minus tan y minus tan x is plus tan x. Be careful. It's not just the negative on the first term here. You have to distribute the negative to both expressions. And now if we simplify the numerator, I have a combine like terms. Tan x plus tan x is 2 tan x. Negative tan y minus tan y is negative 2 tan y, and then the denominator is the same. And then there's only one thing left to do. Every once in a while, look and see what you're trying to get to. The denominators match. The numerators are a little bit different. I can factor the 2. And I reached the other side. So that's the end of the problem. So start on the left, use the two identities from this section, the sum and difference, or the difference formulas for tangent, and did some algebra here. Now, what if we had started with the right-hand side? If I'd started with the right-hand side here, it would have made sense to distribute the 2. It would not have been obvious to me to write 2 tan x as tan x plus tan x, and minus 2y is minus tan, and then break that fraction up. That's not obvious at all. So sometimes starting on one side or the other, it's obvious whichever way you do it, it makes sense to go. But this way, I just went with my gut. Use the difference formula for tangent to get to here. And again, why was that a smart thing to do? I don't want x minus y and y minus x on the right-hand side. The angles x minus y, y minus x don't show up. But x does and y does, so it made sense to do those because there's my x and there's my y. Going the other way, it wasn't obvious to go from here to here. That's not obvious at all. So that should get you through the problems of this section. Again, just like I said in the last section, you cannot start these problems 5 minutes before the assignment is due. These take time, and I make it look easy because I've done a bunch of these. You're not going to be able to breeze through them as quickly as I did here. You're going to have to practice. You're going to get stuck. You're going to have to, throw a trial away and start over. Okay, so get started on these early. You can crank out some of them probably on your first attempt. Some of them you're going to get stuck on. Okay, you're going to have to give yourself time to go back and do those that were more difficult. So get started on the homework right away.